Ground freezing allowed tunnels to be excavated under an active rail yard during Boston's Big Dig. Ground freezing is a construction technique used in circumstances where soil needs to be stabilized so it will not collapse next to excavations, or to prevent contaminants spilled into soil from being leached away. Pipes are run through the soil to be frozen, and then refrigerants are run through the pipes, freezing the soil. Soil contaminated with radioactive elements that leaked from Japan's Fukushima Daiichi nuclear power plant was contained through ground freezing. Boston's Big Dig used ground freezing during some of its tunneling, to allow its wide tunnels to be built under or through soil that supported existing infrastructure that would have been difficult or expensive to support using more traditional excavation methods. But other projects benefit from using more exotic refrigerants, like liquid nitrogen. In northern Canada and Arctic Alaska, passive pipe systems are used that do not require any external power to keep the ground frozen. These systems use in-ground evaporators and above-ground radiators filled with liquid refrigerant. When ambient temperatures fall below ground temperatures, the liquid vapor starts condensing in the radiator, reducing the pressure in the system, causing the liquid in the evaporator to boil and evaporate. This process results in heat transfer from the ground to the air and keeps the ground in a permanent frozen state. Report on an investigation of risk factors associated with the construction of excavated tunnel cross passages in soft soils. The investigation focused on excavations where freezing technologies are used to provide temporary support. The relevant risk factors and their associated probabilistic data were gathered from elicitation of experts. A ranking of the most important factors was obtained for an ongoing project, Sluiskil Tunnel in the Netherlands. This was made possible by modeling the risk factors using Bayesian belief networks. Based on the modeling results, the project has increased its awareness of the relevant risk factors in the construction of cross passages and further optimized the associated mitigation measures.